In this video, let us talk about this problem. This problem was asked in Walmart, and it reads. It's a good problem actually. I was stuck and I researched a bit, and then solution is pretty good. So, given a number n, print how many ways it can be represented as n is equal to a plus b plus c plus d, with the condition 1 is less than equal to a is less than equal to b is less than equal to c is less than equal to d, yeah, and n is within 5000 range. So the first thing which I did was I tried to find any mathematical formula from which we can derive this, but there was none. So the only thing which I came up with, a, b, c, d, all of them should be less than n. That is because there is so the minimum value is 1. So if a or so yeah. So if a is, so basically a cannot be 0, b cannot be 0, so each of them has to be less than n. But it's just an observation which is not really coming handy in the real solution, but anyways, so the first thing which I did was I tried to see how it is playing out. I'll try to run some examples. So if n is equal to 1, then we cannot really have anything, because it's going to be 1 plus, so it's going to be 0 plus 0 plus 0 plus 1, which is not possible because minimum value is 1. So n cannot be 1, n cannot be 2 as well, n cannot be 3 as well, but n can be 4. So if n is equal to 4, then we will be getting 1 1 1 1. So n can be 4. Now n can be 5 as well. So n is equal to 5, which means 1 plus 1 plus 1 plus 1 2 3 4 5. Now we cannot have 2 here and 1 here, because the condition a is less than equal to b. Let me write this down. A is less than equal to b, which is less than equal to c, which is less than equal to d. So it's not possible from here. So that is the reason n is equal to 5 is also one solution, but n is equal to 6 has two solutions, which is essentially 1 2 3, yeah, 3 here, and another solution is 1 plus 1 2 to 4, like this. So like this goes on, and honestly I couldn't really figure it out from here as well. So I checked the net, and there's a good Stack Overflow answer for this question, and I saw the mathematical proof there and I used that only. So the proof is quite interesting, but let me see if I can derive the same proof from these examples we plotted. So so n is equal to 6 is n is equal to 6 is n is equal to 5, and can I, how many ways can I get 5 from 3 numbers? So if I have to represent 5 as 3 numbers, it's going to be less. So So if I have n is equal to 5 and to represent this as 3 numbers, it's going to be 1 2 5, right? 1 2 3 4 5 3, and other way is going to be 1 5 1 2 3 4 5 2 3 4 5. Okay, so to represent 5 as this, okay, so what if I have the first number as 2 3 4 5 3, then it's be 1 1 1. It's not possible, so that is not possible. If you have the first number as 2 and then that's not possible here. Let me see. But for 5 3 like this, then 4 I have n is equal to 5, n equal to 6. So from these two lines we can see that which is these two are basically coming from n is equal to 5 with k is equal to 3. K means the number of numbers possible. In this case it is k is equal to 4. So this is n is equal to 5 and k is equal to 3. Yep. Okay, that kind of makes sense. And again, like n is equal to 5, k is equal to 3. 5 minus 2. Yeah, so n is equal to 5, k is equal to 3 is equal to 4 comma 2. Okay, so 4 comma 2 can be represented as 1 3 and 1 and 2 2. Yep. Yeah, and why is this even possible? That is because yeah, so okay, let me just show you the link. So it's like this. N is equal to 1. There's only one way of possible of putting n. If n is 2, then dp of n minus 2 2 and dp of okay. So the best part I like about this solution goes like this. So it's like f of n comma 4 is equal to f of n minus 4 comma 4 plus f of n minus 1 plus n minus 1 and 3. So if we represent 4 as k, then it should be n minus k and k, and it should be k minus 1. The reason is like if n is equal to a plus b plus c plus d, then n minus 4 is equal to a minus 1 a minus 1 plus b minus 1 plus c minus 1 plus d minus 1. So which essentially, like, if you observe this can be represented as, let's say, a1 is equal to a minus 1, b1 is equal to b minus 1, c1 is equal to c minus 1, d1 is equal to d minus 1, and n minus 4 is equal to n1. So comes down to n1 is equal to a1 plus b1 plus c1 plus d1. It essentially means f of n1 comma k, again, because it's still 4 numbers. So this kind of makes sense. So if we replace this like this, it's going to be f of n minus k, that is n1. Yeah, I wrote 4 here, this is going to be k, n minus k is n1 comma k. So that actually makes sense. And the second part is n is equal to a plus b plus c plus d, which essentially also means, so if a is equal to 1, then the remaining equation boils down to 1 plus b plus c plus d, or n minus 1 is equal to b plus c plus d. Now if we represent a1 is equal to b, b1 is equal to c, c1 is equal to d, then n minus 1 is equal to a1 plus b1 plus c1. It essentially means f of n1 comma k, n1 comma 3, which in the general form will look like f of n1 comma k minus 1. So yeah, it does make sense to have this, the recursion form like this. So f of n comma k is equal to f of n minus 4 comma k plus f of n minus 1 k minus 1. So this is what they have said in their equation as well. And yeah, and dt of n and 1 is 1. So there is only one way of representing. So if n is 5 and number of digit is 1, so it's only one way of representing 5. So that kind of makes sense. So this actually makes a lot of sense, though it's not too intuitive, but when you think about it this way, this actually makes some sense. This mathematical part is quite interesting actually. We are reducing the equation down in this form. Anyways, so let's code this then. So private static int f. So first is going to take n, and next is it's going to take k. So if k is equal to 1, then return 1, else return f of n minus 4 and k plus f of n minus 1 k minus 1. So that is all we need to do, just that we can optimize it a bit further, for example, since like there may be some recomputation in minus 4k, there may be some recomputation like this, so we may need to save this. So let's do that. Hash map n and k, right? It's n and k. Yeah. We don't need a hash map here, but let's do the hash map only. So string and integer is equal to hash map string integer, and it's going to be hm. So here's going to be hm is equal to new hash map, but this has to be static, otherwise you cannot reference it. Now here is going to be if hm dot contains key n plus comma plus k, then return hm dot get n plus comma plus k. Okay, so first do is hm dot put n plus comma plus k comma 1. If hm dot contains key n minus 4 plus comma plus k and 1 is equal to 0, 2 is equal to 0 is going to be temp 1 is equal to it's going to be h1 dot get and this. Okay, yeah. Else temp 1 is equal to this and hm dot put something comma temp 1. Okay, similarly we need to do for temp 2 as well. So it's going to be n minus 1 and k minus 1. What happened? And that's okay, just wrap it in. Okay, wrap this also. Temp 2 is equal to temp 2 is equal to n minus 1 and k minus 1 minus 1 k minus 1 temp 2. Wrap this up. Yeah, so now it's going to be temp 1 plus temp. That should do actually. Let's just test it. Answer is equal to f of n is equal to, what is the value? Let's say let's give 100. I don't have any value to test, but let's see if we get any error or something. Java not a statement. What? Why is it coming like from this one, man? Okay, then we have bunch of errors. What is the error? Stack overflow. Yeah, we are getting a stack overflow here, but this stack overflow online. Oh, too many recursions, I think. It is not exiting the recursion. Let's write code to exit the recursion. If n is less than equal to 0 or k is less than equal to 0, return 0. Let's see. Okay, we have an answer. I don't know if it's right or wrong, but I have an answer. So I mean, this should be right, but anyways, the idea is quite impressive. The mathematical formula is quite impressive. Deriving this was fun, though I took help from Stack Overflow, but that's okay. So this is all for this video, and I'll see you guys next time.